Right now I'm going to do the entire lesson for this combining polynomials. We're going to go through leading coefficients, constants, power, everything along those lines, and as well as multiplying and adding different polynomials. All right, so let's go through here, and hopefully this video will help you. This particular one here, we've got a polynomial here. Remember, a polynomial is typically anything greater than a quadratic we just refer to as a polynomial. So anything with a degree here or a exponent of 3 or larger, then we call that a polynomial. Okay, so with this polynomial, we're going to go through a definition of a couple different things. Number one is the leading coefficient. The leading coefficient is the number that comes before the variable, in this case is 6, of the largest exponent. So the largest exponent in this entire one is 3. Now, whenever I give it to you on your homework and so forth, a lot of times I give it to you out of order. So don't always look for the one that starts it off. Most of the time that will not be right. I try to hide it just a little bit, just to see if you really know what a leading coefficient is. But if it's written in standard form, as this one is, in standard form it indicates that the largest exponent comes first, which this one does. Then the leading coefficient is 6. That's why they call it the leading coefficient. It's the one that comes first when it's written in standard form. Okay, so the leading coefficient in this case is 6. It's just plain old 6, that's all. Then the next thing we're going to talk about is the degree. The degree on this one is 3, and the degree is the largest exponent, period. So if you have many different ones and your largest exponent is 11, your degree would be 11, not third or anything like that. It's just the number 3. Finally, we have the constant, and the constant is the number. It's the number with no variable next to it. It is, if it's written in standard form, it's found at the very, very end. It's just the number. It's constant. The reason why it's constant is it doesn't matter what the value of x is. X could be 5. This one doesn't change. All these other values here change. This one does not. It's constant, so refer to that as the constant. All right, so let's get a little bit of practice on these. I've got 2 different ones here. I want you to find the degree, the constant, and the leading coefficient on both of those. Notice how I did not put them in order. All right, go ahead and push pause right now. Work out your answers. Whenever you're ready, come on back and we'll go through them. Check your answers here. All right, well, hopefully you found out. Let's go to number 2. The leading coefficient, this is the one in front of the highest exponent. The leading coefficient in this case is -1. Remember, there always is a 1 here. It's invisible. We don't write it a lot. We like to save some time, but there is a 1 here. The constant is 16. That one, in this case, was at the end. -16, excuse me. The degree is 11. That's your highest exponent. All right, now let's try 2 more. Try these 2 whenever you're, push pause now. Whenever you're done, you can push play and come on back. Check your answers here. Hopefully you're starting to catch on. To be honest, most students find these to be easier to do than some of the other ones that we've had to do in the past. But that's pretty much the gist of it. That's what we're looking for: the degree, the constant, and the leading coefficient, all of those. So as you do some more of those, you'll get a little bit more practice and it'll become easier for you as well. Okay, now we're used to seeing these. We did these earlier in the year. But these 2, I've got a g of x here, and I've got an h of x here. Here, g of x equals this, h of x equals this over here. We're going to add these 2 together. Okay, we've done those before. And down here, I want you to subtract it. We're going to go g of x minus h of x. Notice how I have it written 2 different ways. G minus h of x versus g of x plus h of x. You can write it any different way. If I could rewrite this one up top here, it would be g plus h of x, similar to this one, just a plus sign. Or you could have written this one here on the bottom like the one on the top. It would just be g of x minus h of x, and that works as well. But go ahead and push pause now, and I want you to try these 2. You should be pretty proficient on these. We've already covered these previously. So go ahead and push pause now, and then try this, and then come back and check your answers. Check your answers here. Now, the way I like to do it, anytime I have ones that I can combine together, I do like some sort of squiggly line underneath each one of these. You'll notice these both have a green squiggly line, meaning these two can be combined. This red curvy line here means these two can be combined, so that's essentially what I did here. And then these two are just the constants. I combine those two there. So just check your answers here. Make sure that you're on the same path, that we're both on the same wavelength, if you will. Make sure that your answers are matching up with what I've got there. All right, now we're going to spice it up a little bit. And this is f times h of x. And you know how to do this. Most of you at this point know how to do this via the FOIL method. The FOIL method we've covered in class before. The FOIL method is nice. It's got that acronym. We can remember how to do it, what order first, outside, inside, last. So if we did that method, that would be the first one. This is our first. X times x gives me x times x. Then outer terms, x times -2. Inner terms are 1 times x, which is just x. And last term, it'd be 1 times -2. Then you'd end up with this one. And this is x squared minus x minus 2. We just combined these middle ones here. This is -2x plus x gives me -x. So that's great. That works really well for binomials. The problem is if I don't have binomials, you see how these are binomials? They have two parts, an x and a 1, an x and a -2. If we don't have two parts, it doesn't work. So it's very, very limited in what it can do. I'm going to teach you a different method now. And this method is going to seem more cumbersome at first, only because you know the FOIL method best. But stick with me as we go through the more difficult ones. They will become a breeze with this method. So I want you to get some practice on this method. But let's go through how to do it first. It's called the box method. The reason why it's called the box method is we're going to create a box. Now this is a 2 by 2 box. Okay, I've got 2 going across and 2 up and down. The reason why it's a 2 by 2 is that's what I have here. I have a binomial times a binomial. 2 part 1 multiplied by a 2 part 1. Now I'm going to fill this in, and it doesn't matter whether this goes up top or down the side. It really doesn't matter. I have to choose one, so I'm going to choose down the side. I've got an x and a 1 here. Now where did I get the x and the 1? I got that right up here. An x and a positive 1. So x and positive 1. Now I'm going to fill in up top here this x and a -2. So my x is going to go right here and my -2. Now technically speaking, we could have done the x and the -2 here and the x and the 1 here. No problem. It would have gotten us the same answer. So don't get hung up on what side it should go on or anything like that. All right, so now that we have those, we're going to multiply everything and fill in our boxes. So x times x gives me x squared. So now I fill that in right here, x squared. X times 1 gives me plain old 1x, or x. We don't write the 1 in front. So -2 times x gives me -2x. Finally, -2 times 1 gives me plain old -2. Now I just need to combine these, and whenever I combine these, in other words, I'm going to add these together. So I've got an x squared minus 2x plus x minus 2. Well, a lot of times, a lot of students find it easier, and I know I find it easier. Right here, I've already got these boxes. I'm going to go ahead and do my squiggly lines right now because I know that those two can be combined. These two can be combined because they have the same variable, they're both x's, and the same exponent. They both have x to the first power. I can't combine these two because this one's x squared versus just a plain old x. So if I combine those two, -2x plus x gives me -x. So my answer is x squared minus x minus 2. My minus 2 came from right here. Now I recognize at this point this one's probably a lot more tedious than the FOIL method, but I want you to try it, especially on the next ones. That'll get you prepared for the more difficult ones. All right, so let's bring some in. Here are your two. I would like you to try these two using that box method, okay? So go ahead and push pause now. Now, the only thing I want to draw your attention to right here, this one only has a 1 part. This one has 2 parts. Okay, this is just a plain old x here. So if we go back to our box method here, let's see. This was what we did. This is the one that we just went through. Okay, this one was a 2 by 2. Well, if I only had 1, let's say if this one were just a 1, I would go a 1 by 2. Okay, we just have an x here. That's it, because that's all there is. And then an x plus 1 or something along those lines. So this one you're going to have a 1 by 2 here. This one you have a 2 by 2. So go ahead and push pause now. Then when you're ready, come on back and push play. Check your answers here. Here's what I mean by the 1 by 2. If I was unclear, this hopefully should clarify just a little bit here, because this is just an x here. And this is 4x minus 24. Now again, I could have gone up and down here. I could have just done the x here, and I could have gone up 4x here and a -24 here, -24 here. that would have worked just fine. So if you did it that way, that's fine. No problems there. And if you switch these two, if you did x here and then -3 and x here and 7, that works. No problem there. All right. Okay, so now we're going to get into something a little bit more challenging here in just a moment. Go ahead and try these two. Now this is where the box method really becomes important for what we're going to do. And if you're struggling on this one, just do number 2 first, then go back and do number 1. Number 1 is a lot easier with the box method, but if you need a little bit more practice, do number 2 first, then do number 1. But go ahead and push pause now, and when you're ready, you can come on back. Check your answers. Number one ended up being a beast. You know, that one's fairly complicated, but hopefully not too complicated. With the box method, I believe that makes it easier. It does for me anyway. And typically when I do it, I just go ahead and do some little doodle here inside the box. That makes it easier for me. But if you want to do it outside the box, there's nothing wrong with that either. All right, let's try 2 more. Go ahead and try these 2. Check your answers. Hopefully you're starting to kind of get the hang of these. I think we're going to try 1, maybe 2 more, and hopefully you'll get the answers on those. You'll see these quite a bit on your homework where this is a binomial times a trinomial. The box method works fantastic for that. Again, order doesn't matter where you're putting these, just so long as you're making sure that this 6p and this -2 go together, because that was your binomial here. All right, let's try these 2. Go ahead and push pause now, and then when you're ready, come on back and push play. Check your answer on these 2. Number 1 was a beast. That thing was big and long. But so if you got that one, then you really understand the concept here. Number 2, I may have tricked some of you, just because this one was addition. This is not multiplication. So that's why your answer may vary from mine. You don't need the box method on this one. These 2 are just being added together. I'm just combining like terms. That's it. So a little bit of trick there for you, but not too bad. All right, the last one, go ahead and try this one. This will be the last one for the lesson. So go ahead and push pause now, and when you're ready, come on back. Check your answer here. All right, so by now, hopefully you're starting to get the hang of it quite a bit. You can try a couple more practice problems. Your homework will be a great way to practice. But if you have any questions, you can let me know. But hopefully this helps quite a bit. You can go back through and review the video if you'd like, and hopefully that will help.